In this video, we're going to go ahead and practice using our multiplying and dividing of fraction skills to some very specific situations. So we're going to go ahead and tackle some word problems. Now for each of these, we're going to go ahead and start by writing a numerical expression, which is really just a fancy way of saying that we're going to write a math problem. So it's either going to be multiplication or division. So we're going to use that to go ahead and represent each of these situations. And then we're going to evaluate, which really just means we're going to solve it. At the end, we got to make sure we do check to see if our answer or our solution makes logical sense. And we're going to make sure we write a conclusion for that as well. All right, so let's go ahead and see if we can get started here. For number one, we see that Beatrix is going to be drinking 3.5 cups of water every single hour. Now, if 4 1/3 hours are going to go by, we're going to find out exactly how many total cups of water that Beatrix is going to drink. So this is a pretty classic multiplication problem because she's doing something over and over again, so it's some repetition. Okay, so we know she's going to be drinking 3.5 cups every hour. So let's go ahead and take that 3.5 and write that down. And she's doing it every hour, so she's going to keep repeating that. So we're going to multiply how many hours are going by. Looks like 4 1/3. So we're going to multiply this by 4 1/3. This should get us the total amount of cups of water that she's going to drink. Let's go ahead and see. If we're multiplying mixed numbers here, we have to go ahead and rewrite these as improper fractions. So to rewrite this 3.5 as an improper fraction, we're going to go ahead and multiply this 3 by 2. So 3 times 2 is 6. 6 plus this 1 is going to be 7. So 3.5 is the same thing as 7 halves. And then we're going to multiply that by 4 1/3 as an improper fraction. So 4 times 3 is going to be 12. 12 plus this 1 is 13. So it's going to be 13 over 3. All right, cool. So we're going to go ahead and multiply these together. Now it's kind of interesting because everything happens to be a prime number here. So if we're multiplying 7 times 13 on top, and we're also multiplying this 2 times 3 on bottom, it looks like nothing can really cancel out here, right? Now we can just go ahead and multiply. So go ahead and do your multiplication as needed. 7 times 13, that's going to be 91. Feel free to write that down on the side if you need to. And then on the bottom here, 2 times 3 is going to be 6. All right, now if you want to go ahead and write that as a mixed number, as we're going to for this particular word problem, 6 fits into 91 15 times with 1 left over. So that's going to be 15 1/6. Now again, if you need to go ahead and do that long division on the side, feel free to do so. So in conclusion, if Beatrix is drinking 3.5 cups of water every hour and 4 1/3 hours go by, you're just going to go ahead and multiply those two numbers together. We're going to get a product, or the answer to a multiplication problem, of 15 1/6 cups of water. All right, let's move on to number 2. For number 2, the question is how much candy, so we're talking about candy here, will each person get if 4 people are going to be sharing 2.5 pounds of candy equally? Okay, so what's the total here? We have a bunch of candy and we're splitting it, we're sharing it, so that means we're going to be dividing. And so our math problem, or our numerical expression, is going to be this 2 1/2 pounds of candy, and we're sharing it, so that's going to be dividing it among 4 people. So this is going to be our division problem. Okay, so let's go ahead and see, how do we divide fractions? Now what we do first is we're going to take this mixed number and rewrite it as an improper fraction. So 2 times 2, that's going to be 4, plus the 1 on top, that's going to be 5. So 2.5 is equivalent to 5 halves. And then we're going to divide it by this whole number of 4. Now how do you write 4 as a fraction? 4 is just 4 over 1, 4 wholes. So this is going to be our division problem. Now try to remember, when we divide fractions, we actually rewrite them as a multiplication problem or as a product. So we're going to keep the first fraction, we're going to change the division to multiplication, and we're going to flip the second fraction, or we're going to find the reciprocal of it. All right, so instead of saying 5 over 2 divided by 4 over 1, we can just say this is going to be 5 over 2 multiplied by 1 over 4. Okay, it's going to be the same thing. Now, we're multiplying fractions here. I don't think anything is going to cancel out nicely here, but how do we rewrite this as one nice fraction? It's just going to be 5 multiplied by 1 on top, and then 2 multiplied by 4 on bottom. There's nothing in common top and bottom. Now, on the top, 5 times 1, that's going to be 5. And on the bottom, 2 times 4 is going to be 8. So that's going to be the product here. Now again, this 5/8 is the product of 5 over 2 times 1 over 4, which happens to be the same answer as the quotient of this 5 over 2 divided by 4 over 1, right? So we're going to use that algorithm of changing the division problem into a multiplication problem. Therefore, if we are taking this 2.5 pounds of candy and we're splitting it amongst 4 people, that's a division problem, so each person is going to get 5/8 of a pound of candy. Okay, let's move on to number 3. For number 3, the question is how much apple juice is each person going to get if 3 people are going to be sharing this 4.5 liters of this apple juice, and that's going to be shared equally. This one's actually quite similar to the one we just did, so what's our numerical expression going to be? Well, let's take the total amount of apple juice we have, which is going to be 4.5 liters, and we're going to be sharing it equally, so that means we're dividing it amongst 3 people. Okay, so very similar to the last one. Let's see if we can go ahead and turn this into a division problem that we can solve. Turning this mixed number into an improper fraction, we can say 4 times 2, that's going to be 8, plus the 1 on top, that's going to be 9. So this is the same thing as 9/2 liters of this apple juice, and we're going to divide this by 3. Now, how do you rewrite 3 as a fraction? Well, again, that's going to be 3/1. Okay, so when we have division problems, we like rewriting these as multiplication problems. So we're going to keep the first fraction, and we're going to change division to multiplication, and we're going to flip or find the reciprocal of 3/1. So instead of saying 9/2 divided by 3/1, we're going to say it's the same thing as 9/2 multiplied by 1/3. Okay, now ask yourself if we have any common factors top and bottom. Well, I see here that the 9 can really be broken up just because the bottom has a 3, so that's going to match nicely. So 9 is 3 times 3 times 1, and on the bottom we have 2 times 3, right? So just breaking down again this 9 into its prime factors, and that's going to help us see that we can actually do some canceling out along the way here. So we can cancel out those 3's to make 1. And so let's see, we're going to have 3 times 1 on top. That's just going to be 3. And on the bottom here, we're just left with a 2. So it's going to be 3/2, which is really, as a mixed number, 1.5. So either one is fine, but I think because we have a word problem, we should write 1.5 here. So in conclusion, if there were 4.5 liters of apple juice and 3 people are going to share it, we concluded here that each one is going to get 1.5 liters of this apple juice. Cool. Let's check out number 4 here. For number 4, we see that a bakery is going to be using 4 1/3 cups of flour every time they make a batch of pastries. So we found out that they used 41 1/6 cups of flour today. So the question is exactly how many of these batches of pastries has the bakery made? Okay, so we know the total here is going to be this 41 1/6, and they're using 4 1/3 cups every time. So to figure out how many batches that we're going to be solving for, we're going to take the total and then divide by how much they need each time. So they need 4 1/3 each time. So we're going to go ahead and divide it to see how many times it fits into it. All right, so classic division problem. And so let's go ahead and see. We have to turn this 41 1/6 into an improper fraction. So what's 41 times 6? Again, feel free to pause and do that multiplication on the side. 41 times 6, I believe, is 246 plus the 1 on top. So that's going to be 247. So I'm going to write this as 247/6. And we're dividing that by what? Well, this 4 1/3 we should also turn into an improper fraction. So 4 times 3 is 12. 12 plus the 1 on top is going to be 13. So we're going to have 13/3. All right, so we have this division problem, but again, our algorithm is going to be changing it into a multiplication problem. So we're going to keep the first fraction, change the division to multiplication, and then flip or reciprocate 13/3. So what's the multiplication problem? It's going to be 247/6, and we're going to multiply this by 3/13. All right, so we're going to go ahead and multiply these two fractions together here. Now, 247 happens to break down into a couple prime factors here. So I'm going to go ahead and show that so we don't have to do some big multiplication. But 247 is the same thing as 13 times 19. And then we're going to have this 3 over here. 6 breaks into 2 times 3. And then we just have this 13 over here, right? If you couldn't find those prime factors of 247, don't worry, just go ahead and multiply and then we can simplify later. But just go ahead and practice doing this. If you can see some common factors, you can see this 3 and 3 are gonna cancel out now. And you can also see that this 13 and 13 can cancel out, which is also really nice here. Okay, so that being said, we're just having 19 left on top here. So we have 19, and on the denominator, we just have this 2. So 19/2, 2 fits into 19 9 times. So 9 times 2 is 18 with 1 left over. So that's going to be 9.5. So taking the total amount of flour they used and dividing it by how much they used each time, we went ahead and calculated that to find out that they must have made 9.5 batches of pastries. Here's number 5. For number 5, we see that Shaylee is going to be running 6 3/4 miles each week. Now, if that's going to be the case, we're seeing that 3 1/3 weeks are going to go by. So it says exactly how many miles has Shaylee run. So this is going to be a classic multiplication problem because it's repeating this each week, and we see a bunch of weeks are going by, or at least a little more than 3 weeks are going by. So she's running 6 3/4 miles for 1 week, and we're going to multiply this by the total number of weeks that are going by, which is 3 1/3. All right, so let's go ahead and rewrite this using some improper fractions. So 6 3/4, 6 times 4 is 24. 24 plus this 3 is going to be 27. So it's going to be 27/4. Okay, let's go ahead and multiply that by 3 1/3 as an improper. So as an improper, 3 times 3 is 9, plus the 1 on top is going to be 10. So that's going to be 10/3. Okay, cool. So let's go ahead and see if we write this as one fraction. Let's go ahead and break this down so we don't have to multiply and simplify with big numbers here, but 27 is going to break into 3 times 3 times 3, and then 10 is going to break into 2 times 5. The 4 on bottom is going to break into a 2 times 2. Those are its prime factors, and then the 3 is just going to stay as a 3. All right, so let's see what we can get rid of here. We got the 3 and a 3. Let's get rid of those. Also, we can see a 2 and a 2 can be canceled out as well. So those just become 1s. On top, we see we have 3 times 3, which is 9. 9 times this 5, I believe, is 45. Let's go ahead and put 45 on top. And what's left on bottom? Looks like it's just this lonely 2. Let's go ahead and put that underneath. So we have 45 halves. And I believe if we turn that into a mixed number, 2 times 22 is going to be 44, which is 1 away from 45, so it's going to be 22 1/2. So in conclusion, if Shaylee's going to run 6 3/4 miles every week, and if exactly 3 1/3 weeks have gone by, then we know that she must have ran a total of 22 1/2 miles. All right, cool. Let's move on to number 6. For number 6, the question is how many pizzas will each person get if 6 people are going to share 4 medium-sized pizzas equally? Okay, so they're sharing. That keyword of sharing lets us know that we're going to be dividing here. So what are we dividing? Well, we have 4 pizzas. That's the total number of pizzas. And we're splitting that among 6 people here. All right, so we have 4 divided by 6. Okay, so a little bit strange here because we have 2 whole numbers, but how can we go ahead and solve this? Well, 4 as a fraction is going to be 4 wholes, or 4 over 1. And what about the 6 over here? 6 as a fraction is just going to be 6 over 1. All right, so let's go ahead and change this division problem into a multiplication problem. We can do that by taking the first fraction, keeping it, and then we're going to change division to multiplication, and then flip 6 over 1 to 1 over 6, the reciprocal. So this is going to be the same thing as 4 over 1 multiplied by 1 over 6. Okay, so rewriting this as one fraction bar here, the 4 breaks down into 2 times 2, and the 1 is just going to stay a 1. The 1 is going to stay the 1 down here, and then the 6 breaks down into 2 times 3. All right, lovely. We can go ahead and cancel out. It looks like this 2 and 2, which is great. On top, we're just left with 2 times 1. 2 times 1, that is going to be 2 for the numerator. And then in the denominator, we have 1 times 3, and that's going to be 3. So what does this 2/3 mean? It means that if we have 4 pizzas and we split them among 6 people, then 4 divided by 6 means that each of these people gets to eat 2/3 of a pizza. Let's take a look at number 7. For number 7, we have a rectangular wall, so it's going to just be a rectangle basically. We know the width is going to be this 8 3/4 meters, and we know the height of it is going to be 3 3/5 meters. The question is we need to find out the area of this rectangular wall. So first I would just start by drawing a sketch to kind of help label things out a little bit. We know the width here of this wall is going to be 8 3/4 meters. So we're just going ahead and label that in as 8 3/4, right? It's good to just kind of label everything and visualize what's going on. Then we're going to want to notice what the height is. This height is going to be 3 3/5 meters. So I'm going to go ahead and write 3 3/5. All right. Now the question is we got to find out the area of this thing. So the area is just the amount of space that's going to be inside of this rectangle. And so the area here, we can just go ahead and label here as capital A. I'm going to say that's the space that's inside this rectangle. So what's the formula for the area of a rectangle? We want to try to recall that the area is going to be equal to the length times the width of it. Now in this case, we have width and height. It doesn't really matter what we're calling them, but we know the width is going to be W, I guess in this case, and then the height here is going to be H. Okay, so I'm just going to use variables to represent that. So what's the area going to be equal to? Let's go ahead and make some substitutions. Now the width here is going to be 8 3/4. Go ahead and substitute that value in. And we're going to multiply that by the height. We know the height is going to be 3 3/5. Okay, so we're going to go ahead and multiply these two mixed numbers together, but let's turn them into improper fractions first. So if we take a look at this 8 3/4, we can do basically 8 times 4, which is 32. 32 plus 3 is going to be 35. So we're going to have 35 over 4. And we're going to go ahead and multiply that by the improper fraction version of this next one. So 3 times 5 is 15. 15 plus 3 is going to be 18. So for this one, we're going to write 18 over 5. Okay, so we're multiplying these two fractions. Let's go ahead and see if we can write it as one fraction here. So on the top, we have 35. We want to go ahead and maybe break that down. 35 breaks into 5 times 7, right? And then this 18 over here, that's 9 times 2. And then the 9 is going to break into 3 and 3, right? On the bottom here, we have a 4, which breaks into 2 times 2. And then the 5 is prime here, so we're just going to keep the 5 the same. All right, lovely. So these are all the prime factors. We can go ahead and cancel out some things. So we can say by these 5s, those are done. They're canceled out to make one whole. And then 2 over 2 also makes 1, so we can cancel those out. All right, cool. The area here is then going to be equal to what? What's our numerator that we're left with here? Well, it looks like we have 3 times 3, which is going to be 9. 9 times 7, that's 63. So we're going to have a numerator of 63 here. And in the denominator, we just have 2. So we're going to put that 2 on the bottom of this fraction. Now, feel free to do this long division on the side if you need to. 63 divided by 2. But we're going to go ahead and say that the area here is equal to, I think, 2 times 31 is going to be 62 with 1 left over. So it's going to be 31 and a half. All right, so we were given the width of this rectangle and we were given the height of it. If we were asked for the area, we're going to go ahead and multiply those together. And if you take one dimension and multiply it by one dimension, then we should get an area that is two-dimensional. So the area here is 31 1/2 square meters, or meters squared. All right, let's check out one final problem, number 8. All right, for number 8, it looks like we have another rectangular wall. This time we know the width is going to be this 8 1/3 feet. However, instead of knowing the height of it, we're being told the area, which is going to be 45 5/6 square feet. So for number 8, we have another rectangular wall. It has a width of 8 1/3 feet and an area this time of 45 5/6 square feet. So we're not told the height of it. So we're given the area and the width. I had a little typo here, but we're going to go ahead and find the height of this rectangular wall. So slightly different problem from the last one. We're solving for one of the sides or one of the dimensions rather than the area. So let's start by drawing a picture. All right, so here is our rectangle. We're told the area, so that's going to be the space inside here. So that's going to be 45 5/6, and that's going to be square feet. That's going to be the inside here. And then we're told the width. I'm going to go ahead and write the width. What color did I use earlier? I used blue and purple, so I'm going to use those same colors here. So blue, I'm going to say it's going to be 8 1/3 feet. That's going to be the width here, and we don't know the height, so we're going to go ahead and label that as h here. So what's our formula again? We know the area is going to be equal to the width times the height, or however you want to say that. So we're going to say width here multiplied by height. And in this case, we can also see that we're looking for this height here, right? We're trying to find that out. So instead of saying area equals width times height, we can go ahead and just rearrange this a little bit. That should be the same thing as the height would be the same thing as the area divided by the width. Okay, so again, just using those ideas of multiplication and division and how they kind of undo each other because they're inverse operations. So how are we going to find the height here? The height is going to be the area. Let's go ahead and make a substitution. That's going to be 45 5/6 Or go ahead and see how many times this 8 1/3 is going to fit inside of it. So if we solve this division problem, we can go ahead and find the height of this rectangular wall. All right, let's go ahead and turn these mixed numbers into improper fractions. All right, first things first, if we go ahead and take 45 and 5/6, 45 times 6, I believe, is going to be 270, if I'm not mistaken. 270 plus the 5 on top, that's going to be 275. Again, if you need to pause and go ahead and do that multiplication, go ahead and do so. And now we're going to divide this by 8 1/3, but let's write that as an improper fraction too. So 8 times 3 is going to be 24. 24 plus 1 is 25, right? So that's going to be 25 over 3. All right, so can we rewrite this as a multiplication problem? We're going to keep this, change this, and flip this, or multiply by the reciprocal. So the height here is going to be equal to, just rewriting this problem, 275 over 6. And we're going to go ahead and multiply that by the reciprocal of 25 over 3, which just happens to be 3 over 25. All right, cool. So let's go ahead and rewrite this as one fraction, and let's try to break some things down here, right? So as one fraction bar, if you need to pause to go ahead and break down 275, feel free to do so. So 275 we can divide by 5. I know that's going to be 55. 55 breaks into 5 times 11. And then we also have this times 3 at the end. The 3 is prime, so we're going to leave that alone. The 6 underneath breaks down into 2 times 3. And then the 25 on the bottom is going to break into 5 times 5. All right, lovely. We see we can cross out some common prime factors here. So the 5 and the 5 can cancel out. This 5 and this 5 can also cancel out. And then also this 3 and 3 can cancel out. So a lot of nice canceling out we can do, and to simplify this fraction. So what's this height going to be equal to? Looks like we only have 2 numbers left, 11 on top, 2 on bottom. So we're just going to write the 11 on top and then the 2 on bottom. Now what is this as a mixed number? 11 divided by 2 is the same thing as 5.5. All right, so in conclusion here, what did we find out? We found out that if we had the total area of 45 and 5/6 square feet, and we knew the width or how wide this wall was, we could divide those two numbers to find out the height or how tall this wall was, and that was going to be 5.5 feet tall. So there you have 8 different practice problems where we went and applied our knowledge of multiplying and dividing fractions. Hopefully you were getting a little bit more comfortable with deciding when to use multiplication and when to use division. And you also practiced turning all those division problems into multiplication problems to go ahead and solve them. If you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.